Hello and welcome to a new video. This is part of my Algebra 1 series. We're graphing linear equations, but we're just getting started on lesson 2. So we're going to talk today about slope. And it'd be super cool if you got a notes page to download and print off so you have less writing to do. And if you'd like to do that, you can click the link in the description or the thing that is floating above my head if you're on a computer. And it's a free notes page. You can, download it, print it, or put it in OneNote and write on it. Whatever you want to do, it's there for you, and then you can pay attention to the video instead of having to write as much down. So check it out. Alright, so as we are working on graphing lines, which is kind of where we're headed in this unit, we need to think about what a line even is. Like, what are the things that make a line unique? So one way I thought of to kind of get you thinking about this is to look at two lines and try to describe how they are different to somebody. So kind of like a guess who game, where if you had to try to get somebody to guess one of these two lines just by describing it, what kind of words would you use without being able to just be like the one on the left or the one on the right? So think about it a little bit, pause the video if you want to, and then start it up, and we'll talk about what I'm hoping that you notice. Okay. So one of the key things that makes a line unique is how steep it is. And not just how steep it is, but which direction it's going in steepness. So for instance, this one on the left goes down from left to right, where the one on the right goes up from left to right. So they're going up and down different directions, if you want to think of it that way. These also don't have the same steepness, right? If you were to put a ball or a skier on these two lines, the one on the left, the person or the ball would go faster because it's steeper. The one on the right, they'd still go pretty fast, but slower because it's not as steep. The other kind of thing that we could talk about, I didn't actually intend for these to be so close, but we could look for specific points. So one of the points that we might look for is where it goes through the y-axis or the x-axis. And these actually go through the y-axis very close to each other. The left one is -5, and the right one is -4. So we have that similarity, but we also have a way that we can kind of distinguish between them because of some points and their steepness. To kind of sum up what makes a line unique, basically there's two things that we could do that we would know for sure that we were talking about the same line, a unique line. One would be for us to pick out 2 points. So like if I'm trying to tell you about a line that I want you to draw, I could tell you 2 points, you draw those 2 points, put a line through those 2 points and pass it on either side, and we would know that we were talking about the same line. The other way would be to have a point and a way to describe its steepness that we both understand. So I'd be like, okay, you're going to start at the point 2, 3, and then I've got to figure out a way, right, to tell you about its steepness. Spoiler alert, that's the whole point of this lesson, is this issue of steepness. So that's cool. That's what slope is how we measure steepness. A vocabulary reminder is the idea of vertical lines and horizontal lines. And the only reason we care about the specific words is just so that as we're talking, we know we're talking about the same thing. So if I said, hey, this is a vertical line, it'd be nice if you thought of an up and down line instead of a side-to-side line, which is a horizontal line. So I'm going to label these here. This is a vertical line, and this one is horizontal. And the way that I was taught to remember which is that a horizontal line looks like the horizon. So imagine yourself looking at a beautiful sunset on the horizon. That's the direction of a horizontal line. And the vertical line is opposite of that. So there you go. Now, let's actually dive into what slope is in the context of math. Alright, so here is this thing called slope. This is a mathematical term for how we describe the steepness of a line. Really, they're basically synonyms of each other. When we talk about slope, we're talking about steepness, we're talking about how much there is, how much change is happening over time, that sort of thing. The other way of thinking of it is it's the amount a line goes up as it's going over. Again, that's basically what steepness describes, right? So in a more technical mathematical sense, here's the information we also need to know. Slope is represented by the letter M. And if you're thinking that's weird, why isn't it the letter S? So I decided to do some extra research on why the letter M is used for slope in things like the slope-intercept form, which is something that we'll talk about soon. And apparently nobody knows why it's an M. Like, they've tried to trace it back in history, and it does not actually appear that it has to do with some other language where the word they were using started with M. So, yeah, it's an M for funsies. But you can think of it like it's a mountain, because slope and mountain, you know, those are similar things. So, M equals the rise over the run. So, if you think about it, if you were to be sitting down in a chair and you had to run out of the room very quickly, you would rise and then you would run. So that's what our slope is like. We're going to think about how much are we going up or down first, and then we're going to think about how far our line runs. Another way of saying that is it's the change in y over the change in x, because rise is talking about this direction, which is our y values, and run is talking about going this direction, which is the change in our x values. And the technical equation or the formula for this is this y2 minus y1 over x2 minus x1. Notice how I described that, by the way, or how I read that out loud. Those little numbers next to our letters are called subscripts, and they're a way for us to distinguish between the two y's and the two x's on top and bottom without having to use completely different letters. So we can use this formula whenever we know what 2 points are. So those points would be x1 and y1. They'll actually give us numbers, but to fill them into our formula, we would think, oh, we've got x1, y1, and x2, y2. And then we'd say, okay, what this is really saying is that we have 1 point and an x and a y. We have a second point and an x and a y. If we had a third point, we could call it x3 and y3, although I don't know why we would, because that's not a part of the formula. But it's just a way so that we don't have to keep using new letters over and over again, because we only have 26 letters. But if we use subscripts, we could talk about 30 different points if we wanted to. Don't know why we would, but we could if we wanted to. So we're going to do two types of problems here with slope in this lesson. We're going to visualize slope, and so that's going to involve us counting the rise over the run. And we're going to find it using this formula when we're given 2 points. Those are going to be our two things that we're going to do. Alright, so this first example, we've got some pictures of graphs, and we're trying to figure out what the slope is. There are two main ways to do this. One is to count, and the other is to write down points and fill in that formula that we had on the previous slide. And it's really up to you. So the formula way is kind of the safe way, as in you can always use that formula as long as you can figure out what two of the points are. The counting way is dependent on, do you already have a graph or not? So because we already have it graphed, then it's actually pretty easy just to count. If we didn't have it graphed and we had 2 points, then we'd have to go to the trouble of graphing it in order to use the counting technique, so it would probably not be as fast. So I want to encourage you to try counting these out with me, because I also think that visualizing it can help us with just like, what are we even saying when we say we have a slope of 1/2, or a slope of 5, or a slope of -3? If we count, it kind of maybe makes more sense. So we'll start with A and then go to the right. And as we're counting, we just need 2 points. Just the way I grabbed these graphs, I happen to have 3 instead of 2. So I just need to pick out 2 of them, and I'm going to count the rise over the run. So I like to go from left to right as I'm doing this. So I'm going to start with the far left point over here. And I'm going to say, how far do I have to go to get to this next point? So I'm basically breaking this part of my line down into a vertical component and a horizontal component. So it's kind of like I'm making a triangle actually out of it, because I want to think I would have to go, if I can only travel on grid lines, I would have to go down 1 and I'd have to go right 4. Or the other way of thinking of that is, well, I was going to say right 4 and down 1, but then that's backwards, right? If I'd started in the middle, I could have thought about it as up 1 and left 4 instead. But either way, the key things there is that I've got a 1 and a 4. 1 is the change in y, 4 is the change in x. but it actually matters that whenever I counted this, I went down 1 and right 4, because down 1 is a negative direction, right 4 would be positive. Or if you counted it the other way, from the middle to the left, or from the right to something to the left, you would have gone up 1, which is a positive number, and left 4, which is negative. Now, what's great is that these are actually talking about the same number, which is an overall negative 1/4. That was an attempt to make that negative be more in front than it is on those other ones, although it still is kind of on top. So when we have this situation where we have to either go down or to the left to count, one of those two things, it's going to make our slope be negative. Anytime we have a down and to the right line, it should end up being a negative slope. And we can remember that kind of with the whole idea of if I divide and I have a single negative, it makes my answer overall negative. Whereas if I have two negatives, then when I divide, that makes a positive. So keep that in mind. That's probably going to be something that we have to think about and talk about some more as we go along to make sure it makes sense. So let's look at B. So these points are really close together, so we're not going to have to make a very big triangle here. Doesn't matter which 2 points I pick, I just need to think, okay, where am I going to go up and down? Looks like I need to go up 1 and I need to go right 1. I'm following the grid lines, just like if you live someplace where they have really nice perpendicular streets, how you can't just like cut across a block. We're going to do the same thing here. We have to like go along these roads, which are our grid lines. So we have to go up 1 and then we have to go right 1, which is this way for you, I think. So up 1 and over 1. Both of those, the positive direction would be 1 over 1. Now, if you decided to start from the right and go left, here's what happens. We would have to go down 1 and left 1, and both of those are negative. That's the situation where we'd have two negatives making a positive. But overall, that is either way is going to be a positive 1 for our answer. So that's how that would go. And then let's look at C. So we're going to count the up and the over. This goes up 3 and goes to the right 4. So we got plus 3 plus 4, which gives us 3/4. If the middle point wasn't here, and we had to count all the way from this one to this one, if you want to see what would happen, we would go up actually 6 here and over 8. So that would mean we would then reduce that to 3 over 4, because we, at this point in math, as much as we can, would like to reduce our fractions so they're easier to work with. So I'm trying to get to the point that no matter what points you pick, we should end up being able to simplify to the same answer as long as we're counting right. The other thing is I made the points on here obvious, and if those weren't obvious, like if somebody didn't mark the points for you, you would just have to go through and find points yourself. Like there are more points that meet at grid lines. So this is another point right here that meets at grid lines. But like if you look right here where my mouse is, that doesn't meet at the intersection of grid lines, so we wouldn't want to use it. This does it. Sometimes though it can be hard to tell. So just keep that in mind, that we want to pick points where it meets at grid lines so that we're not accidentally picking like decimal points. Okay, example 2. This looks really similar, except our lines are purple instead of red, but we're given the same direction, so same idea. But if you do know anything about slope, you may know these are kind of trick questions, and if you don't know, well, get ready. So if I count the rise over the run for A, it looks like between these points I would go up 3 or down 3, but I would not run at all because the points are right over each other. So that gives me 3 over 0, and you can't divide by 0. So we actually have a special word that we call this kind of slope. This is called an undefined slope. And that simply means that this is not something that we can quantify in the same way that we've been trying to quantify it. So the way we've been talking about rise over run doesn't work because we don't actually run at all. You may be thinking, okay, well the same thing should happen here on B, right? Because this is, vertical line, horizontal line, there's going to be a similarity. Sort of. It's sort of the same. Here, we're not rising between our points, but we are running. So we actually, between these 2 points, go over 5, although that bottom number doesn't really make a difference. We could run to any of the points along this line. 0 divided by 5 does actually end up being 0. So the slope of this line is considered 0, whereas the slope of our vertical line was considered undefined. Those kind of things, matter in math. So if you switch them up on accident, you're likely to get the answer wrong, or you will get the answer wrong. You might get partial credit, but you've basically missed the point of the problems. The point. If you would like a really corny way to remember these visually, think about a skier on each of these lines. And let's think about this one actually over here first to set it up. On B, if we put a skier on this horizontal line, I would argue, as someone who likes skiing for the fun of going fast down a hill, that the skier would have 0 fun, and it's a 0 slope. Whereas the skier on the vertical line would have an undefined amount of fun because they're going to continue going really, really fast forever and ever. If you're worried about that skier, don't. They never hit the ground because a line goes on forever. They just are in a perpetual state of undefined, fast skiing fun. Very happy situation, obviously. So that's a way visually you can have kind of a memory technique of which one is which. I really like doing those problems where we just get to count, but that's not the way all of our problems always work. So sometimes we're given points, and that means it would be easier for us to use that formula. It is a pretty neat formula, though, pretty easy to remember. Maybe not like the literal formula, but to remember what it's telling us to do. It's telling us to take our y's and subtract, and take our x's and subtract, and then put them over each other. And the main thing you have to make sure of is that there's 2 things actually. The main thing you have to make sure of is first that you do it in the same order. So for instance, if I use the formula and do the second point minus the first point, I'm going to need to do 6 minus 3 and 4 minus 2. I wouldn't want to swap one of those two. They either both have to be swapped or neither swapped. So that's what I'm going to do on this. I'm going to do 6 minus 3 over 4 minus 2, and I'm going to get an answer, reduce it if I can, and that's my slope. We could have done this on our previous problems where we were given a graph. We just would have had to write down the points ourselves, which we could do if we wanted to. And also here, we could have thought of this much more literally with the formula. I just said, hey, subtract my x's, and hey, subtract my y's. Put the x's on bottom, y's on top. But we also could label these as x1, y1, and x2 and y2, and then have our formula nearby and say, okay, where y2 is, I need to put the 6. Where y1 is, I need to put the 3, and then keep going. We need to do 6 minus 3 on top, which is 3. We need to do 4 minus 2 on bottom, which is 2. We do not need to change this to a mixed number. In fact, I would say that is counterproductive, because if we change it to a mixed number, then we can no longer see the rise and the run as clearly as if it is an improper fraction. And there's also another reason that we'll see in the future as to why we don't normally change it to a mixed number. But I don't want to spoil that for us. Let's try it on B, and I'll try to take you all the way through here in such a way that if you didn't get it on the first one, hopefully you'll get it on the second one. So we're going to fill this in. Now there is an issue that's going to happen here. I mentioned 2 issues earlier, and I forgot to actually say something about the second one. The second issue is that negatives can make us mess this up. So if I want to subtract my y's, if I want to do y2 minus y1, let's think about that, what that means. -1 minus -5. What does it mean to minus a negative? So this is the same thing as when we have double negatives in English. When we have 2 negatives next to each other, they actually make what we have positive. Subtracting a negative actually adds. So this would really be -1 plus 5. And then we will do the same thing with our x's actually. We'll do -18 minus -6. Which minus a negative makes a plus. Go for it. -18 plus 6. And then we work this out. So on top, -1 plus 5 is 4. Bottom, bottom, negative 18 plus 6 is negative 12. And then we simplify this and decide if it should be negative or positive overall. This should be a negative overall, and we can divide them both by 4, so this would be negative 1/3. So that's our answer. Alright, continuing on with some examples here. I wanted to make sure there were plenty of examples, so at some point you might decide you've got the hang of it and you can try it for yourself, and that's great. But we want to continue to subtract our y's on top, subtract our x's on bottom. So we can write out the formula if we want to. We can label these x1, y1, x2, y2. You do want to make sure that that's how you label them, that it's x1 and y1 because we have an x and a y for our first point, and then it's x2, y2 because we have an x and a y for our second point. And then you fill in this formula, y2 minus y1 over x2 minus x1. So 4 minus 5 on top, and negative 3 minus negative 1 on bottom. Anytime you're minusing a negative, you can go ahead and change that to a plus right away, or you can write minus a negative 1 and then change it on the next step. Your preference, whichever. 4 minus 5 gives us a negative 1. Negative 3 plus 1 gives us negative 2. Two negatives when we're dividing give us a positive, so this answer should be positive 1/2. Let's look at D. So this time I'm going to do it without writing down the x2 and y2 and all that stuff. So let's do 1 minus negative 6, and then let's do negative 2 minus 7. So on top we do 1 plus 6, which is 7, and on bottom negative 2 minus 7, which is negative 9. So this makes it negative 7/9. And that's our answer. The last example, and this looks exactly like what we just did, but this is going to be our special two situations that happen. So I wanted us to see what that looks like. So here on A, we've got y2 minus y1. So negative 2 minus negative 2, which means negative 2 plus 2, over 7 minus 5. So on top that gives us 0. On bottom that gives us 2. 0 divided by 2 is 0. So that would be our answer. Whereas on B, we would do y2 minus y1, so negative 6, minus a negative 8, so that's plus 8. That's probably one of the places that you could get tripped up on all of these, is the fact that it was negative 6 and we're minusing a negative means that we switch it to positive. When we are told in a formula to subtract things, but we also have a negative in the mix, then sometimes that subtraction changes things to a positive, right? So this is negative 6 plus 8 on top, 1 minus 1 on bottom. So this is 2 over 0. Remember, 0 on bottom is the one that's undefined. And so what that's asking you to do, if you're trying to do 2 divided by 0, is you're saying, I have 2 of something, I want to divide it into 0 groups. That doesn't make any sense. You can't divide something into 0 groups. Whereas if we have 0 and we divide it into 2 groups, each group gets 0. It still doesn't quite make sense, but it makes more sense than the other way around. Hopefully you can see how that works. So that's how we would have 0 and undefined, that it's the y's not changing that give us a slope of 0. It's the x's not changing that give us a slope that is undefined. Hope you enjoyed this video. I love graphing, and so I'm excited that that's where we're at right now. We're going to take this slope lesson and we're going to build off of it and talk about how to graph lines, and it's going to be totally awesome. If you would like to go to my website here, KStevMath.com, you can get a practice page to go with this so that you can see if you learned something. And don't forget to like, comment, subscribe. Thanks so much. Bye.